Good afternoon. I hope you all had a good lunch. I hope it was as tasty as mine was. I'm glad you all have shown up for a talk like this. It's relatively specific, and I'm hoping that means that all of you are very interested in the topic and will have some really good questions afterwards. This will be about 45 minutes, and then I'm going to try to leave a good amount of time at the end for questions, because there are a lot of things going on in the extension space. There are a lot of things that I think are really interesting, and that are going, I think, to have a little bit of an impact on the way that you develop extensions going forward. But before we get too much into that, extensions are kind of awesome, aren't they? Extensions are great because they allow you to customize the browser in ways that we simply couldn't do if the browser, or when we distribute the browser to a broad audience. Extensions give you the ability to personalize the way that you interact, not only with the web, but with the browser itself. A good example of this is me building this presentation. I used an extension called Clear Cache by a guy named Benjamin Boyko. This is an extension that's really quite excellent, and it's really, really good for web developers, because what it does is you click a button, it clears your cache, and then reloads the page that you're currently looking at. This is really, really helpful, astoundingly so, actually. And what's really interesting about this is that it actually has powers above and beyond what we would give to a normal website. It's able to actually dive deep down into the browser and use some APIs in order to remove data, or if it was a different extension, to change settings or something along those lines. I think we'd all be pretty surprised if we went to a website and it suddenly cleared my browsing data. That would be a bit odd. What's interesting about these, however, is that we see a little bit of bloat in the extension space. We see a little bit of bloat in a couple of ways, two distinct ways. First, we see extensions that are actually requesting more permissions than they actually need to do their job. If we look at Clear Cache, for instance, we see that even though it's only clearing my browsing data, it actually requests host permissions to the entire internet. It does this for a very good reason, actually. It does it because it wants to clear cookies on an origin-specific basis. We don't yet have an API that allows you to do that, which means that the only mechanism that the developer actually has at this point is to request a large and dangerous permission in order to do a very small and focused task. This is something that we definitely want to fix, and there are a lot of things in the extension system that we think we can fix along these lines. The other area that we see bloat in with regard to extensions is the resource usage that extensions actually use when they're active on your computer. We'll talk a little bit about how we're going to try to address both of these issues in a little bit. One last thing we see in the extension ecosystem is the fact that while extensions themselves are quite secure, and we think we have a really good handle on dealing with explicitly malware extensions, we see problems with regard to extensions that are benign but buggy. This means that the extension itself is doing things that are quite important, and it's doing things in a way that simply opens up a hole or two within the extension process itself. This is a bit problematic because, as we said earlier, extensions have permissions that go well above and beyond what's available on the open web. This makes extensions a juicy target indeed. We'll talk a little bit about how we're going to address that with the concept of Manifest version 2. Manifest version 2 is something that was introduced in Chrome 18 as the first set of breaking changes in the extension system. Manifest version 2 basically is exactly the same as Manifest version 1 with a little bit of extra stuff layered on top, a few restrictions, but also a few new abilities. We'll talk about those now. The attacks that I talked about earlier would look something like this, and these are the sorts of things that we're trying to address. Extensions dive deep into a web page by injecting JavaScript. This injected JavaScript might, for instance, in a mapping application or a mapping extension, look for addresses on the page and try to do something useful with them. It might want to display a map, it might want to go out to the Google Maps API or something along those lines. It grabs this information via inner HTML and passes it to the background page via a message. The background page, or a pop-up, or anything along those lines, might then try to use this information by injecting it into the background page or into a pop-up using inner HTML. The problem happens when this information isn't well processed, when you don't really ensure that you're only getting information that you can easily and safely inject via inner HTML. If, for instance, the website injected some script tags inside of the thing your extension is looking for, then you've got a big problem, because at this point, you've just injected untrusted script into a high permission area of your extension. This is a big problem, in fact. It's something that a team of researchers at the University of California at Berkeley have found exists not really to a really wide margin within the extension system. They went through about 100 extensions and found vulnerabilities like this in about 40 of them. However, they found that 94% of the vulnerabilities that they found, which included either loading resources over HTTP as opposed to HTTPS, or this sort of inline script injection issue, would have been solved if both of these issues could somehow be removed. We think there's a way to do that, and I'll talk about it in just a moment. Manifest version 2 introduces then two large changes that we think are going to help make the extension ecosystem more secure, and a couple of small cleanup changes. The two big changes are a default content security policy and web accessible resources. Manifest version 1 is, as of Chrome 18, deprecated. We'll talk a little bit about the schedule that we have in mind later on. Manifest version 2 is very easy to opt into. It's simply an attribute inside of your manifest file. You say manifest version 2, and then we know that you're opting into the new system. The structural changes are very straightforward. First of all, we've made the background property a little bit smarter. Instead of creating a background.html page that really contains nothing except script, you can simply inject scripts by using the scripts property inside background. You could load a library, load your main.js, and go without actually creating an HTML page that doesn't do really anything at all other than load these scripts. And also, we've made some cleanup within the APIs themselves. For example, we had chrome.extension.getTabContents. That's not actually a typo, that was part of the API. We've removed that. Instead, you should use extension getViews. There are a couple of other places where we've combined, or we've removed pluralization that wasn't necessary, things along those lines. If you go to the extension documentation, you can see a complete list of all the API changes that happened. Let's talk then about the first of the two big changes. The first one is web accessible resources. Web accessible resources gives you a mechanism of determining exactly which resources inside your extension should be available outside the context of your extension. If you need to inject a script file or an image or anything along these lines into a website, what you'll need to do is actually specify that resource within your manifest file. Here we've shown web accessible resources public.png. Public.png loads, private.png fails. So at this point, you simply have the ability to whitelist the specific resources within your extension that are available outside the context of your extension. This solves a couple of problems. For instance, we've seen a lot of extension developers using the query string on a options page or a background page or something that gets loaded in order to actually do some work. It was then possible to script that page by loading it outside the context of the extension. This will remove that sort of vulnerability. Content security policy, then, is the second of these two large changes within Manifest version 2. This is probably the biggest change, and it's something that I'm going to spend a good amount of time on walking you through because it's very important. Content security policy gives you a mechanism of mitigating the risk of cross-site scripting attacks by very specifically whitelisting the origins that are allowed to load resources inside of a certain context. In this case, we're defining a policy for extensions that enables you to determine that origin 1, so my website, I should be able to load resources. I should be able to load script from that website. I shouldn't, however, be able to load resources from eval.example.com. If somehow people were able to inject code into my background page that tried to load resources from an unwhitelisted origin, it would simply fail. This gives us a good measure of security, and it's something that we're really excited about, not only for extensions, but also for the open web. There's going to be a really good talk on Friday that I think you should all attend if you're at all interested in security, and really everyone should be. There's a lot of detail on this. I'm not going to go into a whole lot of detail about content security policy itself, how it actually works, and how you define a content security policy. We've just published an article on HTML5 Rocks, which is an excellent website, by the way. If you go there, you can get a really good overview of content security policy, and I think that's probably a good use of 10 or so minutes of your time. The default content security policy that we're defining within the context of Manifest version 2 is script source self, object source self. This has a couple of impacts. The basic idea is that you can only load script from inside of the context of your extension, so inside your extension package, coming from the same origin. You can also only load Flash and other plugin information via the same mechanism. So these sorts of things we would like you to bundle with your extension when possible. It has a couple of impacts then. First, no JavaScript can be loaded by default from third-party servers. No objects can be loaded by default from third-party servers. No inline JavaScript. This includes script tags. It also includes things like inline event handlers and JavaScript URLs. It's simply impossible, you see, to differentiate code that was injected maliciously from code that was inlined in your web page intentionally. There's no difference between the two as far as the HTML parser is concerned. It's simply impossible to make that determination. Content security policy then takes the safest route, which is banning it entirely. No eval. This is an interesting topic, and we'll talk about it a little bit more later on. But for the moment, by default, eval is disallowed. This includes not only eval itself, but also things like new function, set timeout that uses a string, and set interval that uses a string. So anything that takes strings and converts them directly into executed JavaScript is something that we simply can't allow within the protected context of the extension. Ideally, this means that we'll be free from XSS attacks within the context of an extension. That probably isn't completely true, but content security policy gets us a heck of a lot closer to that than we are today. So let's talk a little bit more detail about third-party resources. I said that by default, you aren't allowed to load third-party resources. This is the case. You can, however, loosen this policy to include HTTPS sources, that is, secure HTTP sources as opposed to HTTP sources. If you go to a coffee bar and hook up to their Wi-Fi, you really have no guarantee that anything you load over HTTP is actually what the server sent you. It's incredibly trivial to go in and manipulate that content, injecting new content or changing it entirely. HTTPS, however, is an entirely different story. Because it's encrypted, it's much, much more difficult to inject anything malicious into an HTTPS stream. At that point, we feel pretty good about allowing you to load things like Google Analytics over HTTPS as opposed to HTTP. So if there are third-party JavaScript that you need to load within the context of your extension, we would ask you to specify it within the content security policy that you define for your extension. You could write something like this, script source self, which means you can load things from your own extension's origin, but also HTTPS SSL googleanalytics.com. This will enable you then to load Google Analytics, do the things you need to do with this external library, but do it in a very safe way. We'd actually, however, be thrilled if you locked things down even further than the defaults that we've set. You can start with a default source of none, and then list every single type of resource that you need to load and the origins associated with those resources. This gives you a higher degree of security than simply using the defaults that we've set. The defaults take care of the most dangerous things, that is scripts and objects. But if you want to deal with everything else as well, we'd be quite happy. Inline JavaScript, however, is something that we simply can't loosen. This is actually the core of content security policy. Because you can't differentiate between maliciously injected code and non-maliciously intentional code, intentional code, we simply can't allow this policy to be loosened. If you have code that looks something like this, it's actually not really best practice anyway, right? We have JavaScript, CSS, and HTML that all have very different purposes. HTML is there for markup, CSS is there for your presentation, and JavaScript is there for behavior. Separating those out into separate files makes your code easier to understand and is really best practice anyway. If you have code like this, you can very easily rewrite it into two separate files. So instead of having an inline event handler on a button, you would have an external JavaScript file that gets loaded. This JavaScript file would hook up an event listener, and at that point, when you click on the button, amazingness will still happen. You'll get the exact same effect, but you'll get it in a way that we can ensure is safe. Eval, on the other hand, is a bit problematic. We can't really allow it by default because your extension might be working with untrusted data coming from users. So user-generated data being potentially turned directly into executed JavaScript. That's problematic, and it's simply something that we can't allow within the context, within this high permission context of an extension. We understand, however, that it's pretty important for a couple of use cases. There are a few of you that really, really need to use eval and especially eval-like constructs. New function, for instance, is used in a wide variety of templating libraries. And we understand, we've heard the feedback, that that's incredibly important to the way that many of you develop. We think we have an alternative or a workaround for this that we're happy with and that we hope you'll be happy with as well. The idea is that you create a sandbox in which eval can execute in a non-dangerous way. Let's talk a little bit about how that might work. We have your extension, and inside of your extension, you create an iframe. This iframe is sandboxed, meaning that it has fewer permissions than the extension itself. We defined in the previous page sandbox.html. We load sandbox.html in an iframe. It's then pushed off into a separate origin from your extension. This means it doesn't have access to any data that your extension has stored, and it doesn't have access to the dangerous chrome.star namespace. So any of the things that your extension can do, you'll need to deal with the sandbox in much the same way that you deal with content scripts and injected scripts. You'll pass messages into the sandbox containing data that you'd like to see processed. Then you'll pass data or process data back out of the sandbox into your extension, giving you the ability to, for instance, pass in a context for a template and get templated HTML or rendered HTML back out. At that point, you can inject that HTML into your pop-up page or into your background page without worrying about whether it's dangerous or not, because that new HTML, that newly generated HTML, would then be executed inside a context that's protected by content security policy. Even if an attacker was completely able to hijack everything within your sandbox HTML file, the worst they could do is present links or something that would be useful for a user or that looks useful for a user to click on. They couldn't actually execute any code, they couldn't exfiltrate data. At that point, we're pretty happy with this as a compromise. The code for this would look relatively straightforward. As I said, you would inject an iframe, in this case sandbox.html, which again was defined in the manifest file as being a sandboxed file. When this file is loaded, you would fill that iframe with templating goodness. So at this point, I'm using something like handlebars. Many of you are using different frameworks. They would generally work the same way. You want to inject or you want to code a sandbox page that contains all of this templating information, and then create sandbox.js, which will basically create an API on top of your sandbox that allows messages to be passed in with a certain command and a certain context. Then you'll be able to execute that information. So I create a template at the top of the page. This is just the way handlebars works. And then I listen for a message event. When a message event comes in with a command of render, then I post a message back to the extension containing some templated data. So I execute template with the context that I passed in. This gives me new HTML, I pass it back out, and I can do whatever I want with it in a relatively safe way. That side would look like this. When I click on the browser action, I pass information into the iframe content window, and I get the information back out as a message event. This gives me the ability then, as I said, to sandbox the way that eval works. This means I can do the dangerous things, but I do them in a context in which those things are no longer dangerous. The support schedule for Manifest version 1 is as follows at the moment. Chrome 21 is coming out mid to end of August. At this point, no new extensions built using Manifest version 1 will be accepted in the Chrome Web Store. It's not, however, the case that old extensions at this point will have any problems whatsoever. Old extensions will be grandfathered in. So if you currently have an extension in the store that's using Manifest version 1, you're fine for a little while. But this is our message to you. Manifest version 1 is deprecated. We really need to move to a system that is more secure, that gives us these guarantees in a way that we simply can't do now. We've had content security policy in the extension system for a while, and it simply hasn't gotten enough adoption for it to be useful for us as a security mechanism. We're going to need to migrate extensions over to the new Manifest version, and we're doing it with a schedule as follows. Chrome 23, Chrome will stop packaging Manifest version 1. This means if you want to package a Manifest version 1 extension for distribution outside the Chrome Web Store, you won't be able to do it through Chrome anymore. You'll need to write something on your own. Sometime in Q1 2003, we're looking at Manifest version 1's not appearing in search any longer. This is the point at which old extensions are going to start seeing impacts from this. Sometime in the middle of 2003, Manifest version 1 items will simply be unpublished from the store. We're going to be publishing warnings about this. We're going to be sending emails out about this. We're going to make it very clear what's going on, and we're very much hoping that we can get you guys to come along with us. In 2013, whenever we're happy with the way things are going, we'll turn off manifest version 1 inside of Chrome, period. This means even extensions that are loaded within an enterprise, for instance, will simply not work anymore in new versions of Chrome. So we're definitely looking to move people over relatively quickly from manifest version 1 to manifest version 2. We're really looking for feedback about this. We want to know what the pain points are so that we can make the system better. We've heard your feedback with regard to templating. We think sandboxing is a good alternative there. If there are other pain points that are really causing problems in this migration, we really want to hear about it so that we can fix it and make it easy for you guys to migrate from one to the other. We've talked a little bit about manifest version 2. It's a big change. It, however, has a lot of benefits that we think are really valuable. And it also is going to enable us to build new APIs that are more targeted, and these new APIs, we think, are going to be really interesting for developers. Let's talk a little bit about some of them. So many of the APIs that we've produced over the last 3 years in the extension framework have been very much like chainsaws. They're large, they're powerful, but it's relatively easy to sever a limb if you're not being careful. What we'd like to produce is something much more like X-Acto knives or scalpels, something that's very fine and detailed, that gives you the ability to do the things that you need to do, but do it in a way that's much less dangerous. It doesn't require the same permission set, specifically with regard to host permissions. What we also want to do, however, is reduce the number of resources that are used by extensions on an ongoing basis. You see here that I have a lot of extensions installed. I've basically installed every Google extension that I could find on the first couple of pages of the Chrome Web Store. What we see here is, first of all, it's relatively difficult to use, but if we look at the task manager, we'll see that all of these extensions, even though they're doing absolutely nothing right now, are taking up a large number of resources, anywhere from 20 to 30 meg, depending on the extension. It isn't quite as bad as it sounds. Much of this memory is shared because of the multi-process model, but it's still much more than we think extensions should be using when they're not doing anything at all. We'd like to kill off those processes, and we'd like to shrink the amount of resource that's being used on an ongoing basis. The mechanism we're looking at for doing that is event pages. We published a blog post on chromium.org about this, I think last week. The idea of event pages is that they work very similarly to background pages, but they disappear when you're not actually using them. So we can kill the process entirely. This has a large number of benefits. First of all, by killing the process, we ensure that even if there's a leak somewhere in your extension, by killing that background process, we can also kill the leaks. So even if there's a leaky extension, we reclaim all of those resources simply by reaping the entire process. It also gives us the ability to move to a more event-driven model, something that we think is really going to be useful for low-memory devices like Chrome OS. If you're looking at a Chromebook, it's not going to be possible for you to load hundreds and hundreds of extensions if each of them is taking up memory in the background, regardless of whether they're active or not. We want to make sure that on these low-resource devices that we point those resources towards the things that you're actually doing as opposed to the things you might be doing. Event pages are opt-in, and it's very straightforward. When you use the new background page syntax, you simply write persistent false. So you set this flag to false, and at that point, your background page will simply be killed when it's not doing anything useful. The life cycle is as follows. We load the background page on installation. At that point, we record all of the events that are registered within the background page. So your background page might look something like this. It might be a main.js. You might register for a couple of events. Chrome will remember and persist all of these events. Then when your background page is killed, we can start it up again based upon these events, based upon user interaction. So in the middle, I register for Chrome browser action on clicked. Chrome will remember this. Even when the background page isn't there anymore, if I click on the browser action, it'll restart the process, spin it back up again, and execute, or pass in this event so that I can execute something useful. You'll see two new events, Chrome Runtime on installed and Chrome Runtime on suspend. Chrome Runtime on installed is triggered on installation, but also on every update. This gives you the ability to determine whether or not the extension is being installed for the first time, which gives you a good opportunity to use the Chrome storage APIs in order to set some values, to do some setup, to set flags or whatever it is that your extension actually needs. But on update, you could also do things like migration. So if you're using IndexedDB in the background, you could at this point check the version of the current database, and if it's the old database, then migrate to the new one. So this, we think, is going to give you some good opportunities for dealing with these sorts of events that were difficult to deal with in the past. Chrome runtime on suspend is called when the background page is about to be killed. So when Chrome recognizes that the background page isn't doing anything, it doesn't have any pop-ups open, you're not inspecting it at the moment, it doesn't have any active network requests and things along these lines, we'll go ahead and send an on suspend event to the background page. You'll have a little bit of time here to do any sort of last-minute saving. This isn't a good time to start, uploading 10 megs of data to an external server. You should be saving as you go. Basically, you should be ready to die as soon as this thing is called. Or your process should be ready to die. You, of course, should not be ready to die. Chrome runtime on suspend will be called, it'll execute, and then some arbitrary period of time later, your process will be killed entirely. It'll be spun back up again when any of these events are triggered. It's not, however, the case that you can only respond to user-driven events. Some of you are writing extensions that need to go out to the web, pull some data, store it locally, and then be ready and responsive for your users. We've then created an alarms API that works exactly for this use case. At some point in the future, you can wake your extension back up, do some processing, and then go back to sleep. For example, you can create a period in minutes, which simply means that your extension will be triggered every 10 minutes at this point. Every 10 minutes, you can go out to the web, pull some new information, store it locally, and be ready for your user's response or ready to respond to your user whenever they actually interact with your extension. You can do this as a one-off, as a repeating, or at some specific point in the future. We give you a lot of options here. Another area in which we see extensions actually requesting more permissions than they need is keyboard shortcuts. Key bindings at the moment are a big mess in extension land. To bind to a specific keyboard shortcut, you have to request host permissions to all URLs, so the entire internet. Then you inject a content script that listens for key presses, and you really, really hope that this content script doesn't actually interfere in some way with the application that your user is running, or get overwritten in some way by the application your user is running. We can do much better than this. Our attempt at doing better is the Key Bindings API, which is currently an experimental. The Key Bindings API is a declarative API that allows you to say, I want to respond, or I have a couple of commands, and these commands should be associated with specific suggested keyboard shortcuts. This should be, I think, be relatively straightforward. You define a list of commands, each of the commands has a description associated with it, and each of the commands has a list of suggested keys. You can set up different suggested keys for the default or for a specific platform. We think this gives you a lot of flexibility. Inside of your extension, it'll look a little bit like this. You'll hook into the on-command event of key bindings, and at that point, you'll get a string. And that string is going to be the same string you defined in the manifest file. You'll get this command, you can respond to it in some useful way. What you might have seen is execute browser action as a specific command that will allow you to execute the pop-up or execute the on-clicked event of your browser action with a keyboard shortcut. This is something that hasn't been possible before, even by injecting content scripts, and it's going to be a big benefit, we think, of moving over to the Key Bindings API. You'll be able to, for instance, just do a pop-up by executing some keyboard shortcut. There are a couple of to-dos here. It's not done. As you notice, it's an experimental. Mac support is simply non-existent at the moment. We're working on it, but it's going to take a little time. And we also don't have any UI for dealing with conflicts. We have some UI for assigning shortcuts, but it's just not there yet. We actually just implemented saving last week. You could look at it beforehand, but this week you can actually save new keyboard shortcuts. So we're getting there, slowly but surely. Let's talk a little bit about network APIs. There are a couple of really interesting APIs that we've released over the last year, and the usage of those APIs has surprised us in some ways, but is also, we think, pointing towards things that we can do in the future to make things better. That future thing is going to be a declarative web request API. To understand why that's important and why that's valuable, let's first talk a little bit about the web request API as it exists today. The web request API looks something like this. In this case, I want to block my user from going to malicious websites. As we all know, malicious websites have an eval equals 1 flag as the last get parameter. I mean, it's great. It's really useful that they do this because it allows us to block their requests. Blocking a request looks something like this. Chrome.WebRequest on before request. So before the request is actually sent out of my computer, do something useful. You see the last item here contains a few flags, in this case blocking. This is the first synchronous API that we've created, and the synchronicity of the API is a little bit problematic for us. It's problematic for the following reasons. Chrome looks more or less like this. We have a browser process that manages a wide variety of renderer processes. Each tab, more or less, has its own renderer process. So if a web page wants to load a URL, if they're using the web request API, the web page will say, okay, I'd like to load this image. That request will be sent up to the browser. The browser then needs to make a decision. Should the web page load the image or not? To make that decision, it sends something down, or it sends a message down to the extension. The extension, or the message, then hops from C to JavaScript in order to make the determination to do something useful, to execute this code up above, and then sends that information back to the browser process. In parallel, it's sending these requests out to all the extensions that have registered for a web request that filters into this specific request. Sending all of this information back and forth between the processes is costly. It's more costly than we actually expected it to be. If you go to Chrome histograms, you can see exactly how costly it is on your computer. I created a bit of a torture test here, but you see, actually you probably can't see because it's really small, but at the bottom here, the longest request, or the longest wait between sending a message from my page to the extension and back was over 2 seconds. Now this isn't typical. Most of the requests are happening in well under 100 milliseconds. But over 2 seconds to process a request is incredible. That's much longer than it should actually take to load the resource in the first place. We need to do better than this, and we think we can. The Declarative Web Request API instead is a declarative mechanism for determining whether or not a request should be blocked or redirected or anything along these lines. You declare a declarative web request permission, and you create a series of rules. You might do this in the on-install event of your background page. You create a rule. Rules contain conditions and actions. If the request matches the conditions, so if they're going to eval.example.com, then we're going to block the request. Once we've created this large array of rules, we add all of the rules into Chrome. And we can do this incredibly efficiently. Adding the rules to Chrome standardizes the way that we deal with network requests, giving us the ability to very efficiently store the information in the browser process as opposed to pushing everything down to the extension process. This has a couple of advantages. First, we don't have to do so much IPC messaging between processes. But second, because we've defined a single mechanism for declaring this sort of these sorts of rules, we can do it very, very efficiently indeed. You can set conditions on basically every piece of the URL. So you can look for ports, you can look for paths, and you can look for query strings. You can also look at the entire URL if that suits your use case. We haven't yet added regex for the entire URL. We're working on that. What we have added, however, is a variety of conditions, or I'm sorry, a variety of actions. The actions that are associated with these URLs are, for instance, cancel requests. This is probably the most common. You simply don't want to make this request in the first place. You don't want to send any information out. What we also allow you to do is redirect. And you can redirect not only to a specific URL, but you can redirect using a regex. For instance, you could redirect all HTTP requests to the exact same request on HTTPS. Unfortunately, it isn't quite that simple, which is why HTTPS Everywhere exists. But we think this is going to give extensions like HTTPS Everywhere the ability to create this really complicated rule set without actually jumping into JavaScript in order to make that determination. We also give you the ability to deal with the request headers and the response headers. So you can set and remove headers simply based upon the URL that the user is actually going to. You can ignore rules. So if you're familiar at all with email, you've probably set up a bunch of rules, and you have things like, if this, then do this, and ignore the rest of the rules. This allows you to set a priority with each of these rules. So when you create really complex rule sets, multiple things might match. And you want to make sure that the right thing actually executes based upon that action. So you set a priority with the rule, and at the end of your actions, you can say, ignore any other rules that are lower priority than this one. The active tab permission is the last new thing that I want to talk about today. The active tab permission is something that we think is going to be really quite powerful. It's something that we, I think, are very excited about. What it does is allow you to deal with specific hosts without requesting permission for those hosts. We see a lot of extensions out there that really only need to interact with the page the user is currently viewing. For example, Google has a dictionary extension, which allows you to grab a word out of a page and give you a definition for that word. It's incredibly useful, but in order to act, it injects content scripts into every page that you go to, and then listens for a browser action. When you click on the browser action or you use a context menu, it then grabs the thing that you've currently selected, does something useful with it, and displays a result to you. It has to request host permissions to every website on the net in order to do that. Active tab permission would give it the ability to, based upon a user's gesture, inject script into a page that it hasn't requested permissions for. In this case, I would request permission for active tab and tabs. You'll note that I'm not requesting any host permissions at this point. I can, however, listen for a browser action. I could also listen for a context menu and act upon that action by injecting script into this page. We're using the user's interaction with either the browser action or the context menu in order to give the extension the ability to inject script into this new context, even though it hasn't explicitly requested permission for it. We think this is going to be really useful not only for the Google Dictionary extension, but for the wide variety of extensions that we see in the Chrome Web Store that are looking for exactly this sort of functionality. We see many extensions that really don't need permission for the entire web, but they don't have any other mechanism of doing it. We'd love to see people experimenting with this. It's in Canary right now. It'll be in dev relatively soon. So we've talked about a wide variety of things. What do we actually want to see happen? And what do we think that we can do together as a community in order to strengthen this ecosystem? The first thing is to really take a hard look at Manifest version 2 and start migrating extensions over to it. Manifest version 2 gives us really good guarantees about the way that the extension can function and the security that comes along with that. If we ban inline JavaScript, there's a huge win associated with that, not only for us, but also for the users that are using the extensions at the end of the day. They get a safer ecosystem and they can more easily install extensions with the understanding that those extensions are safe. We'd love to see people start migrating over to Manifest version 2 and, as I said, talking to us about the pain points. We've really heard what people have said with regard to eval. We've created a workaround for that. That's the model that we'd like to see going forward. We really want to understand what the problems are that you guys are going to face when you're building extensions in the future under these new restrictions. You can report issues either by filing a bug at new.crbug.com or by hopping onto the Chromium Extensions mailing list. So you can send an email to chromiumextensions@chromium.org or subscribe to the mailing list yourself if you'd like to do that. That's via groups.google.com. We'd then like for you to take a look at the new APIs that are coming out. In the past, we've had the concept of experimental APIs. We're going to start doing away with that slowly. Instead, we're going to start experimenting via channels. That is, an API will be available in dev, but not in beta, or in beta, but not stable. This, I think, will give us a much larger audience for the new APIs that are coming out. Instead of only targeting the users that are currently, that have set the experimental flag. That means they've gone into flags, they've set experimental and so on, which is a very small number of people indeed. You'll be able to target everyone who is on a certain channel. So everyone using dev can start installing extensions that are using these new privileges or the new extension APIs that are coming out. And as soon as that moves to beta, your audience broadens even further. We think this will give you the ability to start playing around with extension APIs earlier without forcing your users to do something that they're not at all comfortable with. That is, going in deep into Chrome and setting some sort of flag that they don't understand. Finally, again, we'd really love to hear what the issues are, what the pain points are, what we can address, and what we can address together. What the things are that are really going to be problematic going forward, because we want to solve these things. We want people to start using the new Manifest version and the new APIs, and that's simply not going to happen if there are blockers. So we want to understand those blockers, and we want to fix them to the best of our ability. You can contact me at any of these places. So I'm on Twitter, I'm on G+, this is my website, on GitHub, or you can send me an email personally, mkwst@google.com. I'd be happy to hear from you, and I'd be happy to hear from you now if you have any questions or comments. There are microphones in the middle, so if you can walk over, then everyone can hear the questions.
So I have two questions, if that's okay.
Yeah, that's fine.
Cool. So But with these background pages that die when they're not being
Event
used,
pages, yes.
what's the preferred practice for push notifications to Chrome extensions?
Push notifications will be events just like any other. That is, you can subscribe to them. Chrome will recognize that you've subscribed to them, and when one comes in, you'll get an event notification in exactly the same way that you would before. Okay. There really should be very little difference with event pages. It's just subscribing to events and dealing with that subscription.
Okay, cool. My other question is, I can't help but notice some parallels between like malicious Chrome applications being out there and malicious Android applications. Mm-hmm. And the Android team at Google has made like Bouncer, which for those who aren't familiar, it's a dynamic analysis tool that runs your Android code, and if it detects malicious behavior, it rejects you basically. Do you see anything like this in the future for Chrome extensions?
As I said, I think we're pretty happy with our ability to deal with malicious Chrome extensions, the extensions that are actually doing damage intentionally. The thing that we find much more difficult to deal with are the benign extensions that are doing really good things, but are doing them in dangerous ways. These sorts of things we think are better addressed simply by applying a policy to the extensions that forces them to do things the right way. I hope that answers your question.
Sounds good, thanks.
Thank you.
Are there any plans to have more tighter integration for having my web application detect that you have an extension installed and be able to have them communicate together? Because right now, if I want to pass information between an extension and my page, I have to use an inner HTML of some random element on the page.
And if you have an extension that should interact in some way with a page, you can have an interaction point. Well, I mean, you can send messages to the extension. So if you have a defined API, you can send messages over. You would have to have that endpoint as a web accessible resource. So that's where the new stuff would come in. What we would also suggest is that you use the inline install mechanism that would actually enable you to install the extension if it isn't already installed on the website. So you could prompt the user and then install it directly from the page without hopping over to the web store.
Gotcha. And one more question is there any plans to, for example, we wrote a Chrome extension that would let users give us feedback about an application, or if they experienced a bug with our application, they could send us a screenshot basically of what they were looking at when it happened. Mm-hmm. We wanted to be able to get access to the console log from the extension so that we could see what error they got. Is there any plans to get that kind of information available?
Within your background page, you should be able to use window.onError in the exact same way that you do on web pages. That would give you any errors that happens, and you'd be able to report those in the same way that you can on the open web.
But not like, for example, informational messages, debug messages we might output.
No, if you're outputting the messages, then you could package those up in some way and save them locally, and then if an error occurs, you could send them. But there's no mechanism that the extension framework itself gives you to make that possible.
Gotcha, thanks.
Yeah, no worries.
Hi. So as the Android is having the Chrome browser, do you guys have any plan for building the extension for the Android?
There's nothing to announce at this point. It's difficult, and it's difficult.
Okay, thanks.
Nice talk. I have a question about the permissions. It's really cool to have permissions and extensions. That's the very cool way what has been done. But for the normal user, everyone's saying, when you have in Chrome App Store, you have all these permissions saying all browser history,
yes,
every single thing. Is that going to be taken care of as well? If we like the whole point of us putting all these permissions in our extensions right now, it's going to be more work for us to figure out what we need. But it'll be cool if Chrome App Store says, oh, this user is using WebSockets, or this user is using those kind of new HTML technologies that you're exposing this website, you're exposing this hacker website and stuff like that.
I think what I should have made clearer earlier is that by not requesting host permissions, we can actually make the permission messages much less scary. Instead of requesting permission to the entire internet by having all URLs as part of your host permissions, if you only request active tab, because that always goes through a user gesture, we actually don't have to show a permission warning at that point. The permission is explicitly granted by the user when they directly interact with your extension.
So that's on the timeline to fix up the messages?
It's on the timeline in that we're going to create new APIs that are less dangerous, and those new APIs will come with less scary permission messages because they simply are less scary.
And my next question is, I like the on suspend and on install, because before we used to do the version check all the time.
Mm-hmm.
And for the on install, is there a way to know if it's updated or installed without doing a local storage check?
No, you would have to set something locally.
And how about the on suspend? Is there a way to revoke suspension?
No.
So we can't do event pre-vault?
No, if your extension is suspended, it's going to be suspended unless the user interacts with it in some way, or unless it's being kept alive by either having a long network request.
So there's no way to wake it up instantly, like.
That would be the alarms API. So you can say that at some point in the future, I want to wake up again. So inside of the on suspend event, you could certainly say, in 5 minutes, wake me up to do something, but that would be your mechanism.
Okay, thank you.
Thank you.
Hi, are there any updates on detecting when a user uninstalls an extension?
None that I know of, no. That's definitely something that we can talk about. I'd suggest, if there's not already a bug filed, file a bug and send it to me.
It's there.
Okay. Send me the ID if you don't mind.
I can do
and
that.
I'll take a look at it. Thank you.
Thank you.
Thank you.
Did you have question about potentially selling extensions. Is there a plan in the store to extend the app's like purchasability APIs into Chrome extensions?
There's nothing to announce. I don't know of any plans.
All right. Okay, then subset to that, what would Chrome's, or potentially, what would the thought be on, hypothetically, bundling an app in the store and the app's sole existence just be a license file that I can sell, and then use the Chrome management permissions to check the existence of installation of both, and thereby shoehorn some way to sell an extension. If I manage to do that, would that somehow get me kicked out of the store?
It sounds interesting.
Yeah. All right, well, I'm going to
it's the first I've heard of something like that, so.
Currently, building cross-browser extensions is like across different browsers is a pain.
Mm-hmm.
Like the more and more we use like advanced Chrome APIs, we are like alienating ourselves from like Safari and Firefox. I'm not even talking about IE, like like browsers, even like Safari, which uses WebKit, like we are alienating ourselves. Are there like any plans from Chromium, like to prescribe like a base set of APIs, or like form a consortium, so that like these are some basic APIs which should be present across all the browsers?
Mm-hmm. Part of the
what
issue.
is your, sorry, go.
Yeah, sorry. Part of the issue, I think, is that extensions really enable you to dive deeply into the way that a browser works, and they're really well bound together with the way the browser itself works. I think there probably would be value in figuring out some way of dealing with extensions in a cross-browser fashion. What we think, however, is that extensions are really based on web technologies, and to whatever extent possible, you should be building things in HTML and CSS and JavaScript, and those sorts of things, especially the backend portion, should be reusable across browsers. I think you can look at extensions like HTTPS Everywhere that have presence on multiple browsers, and what they've basically done is created a library in the backend and then put a thin shell on top of that library that lets them target both Firefox and Chrome. We think that's a pretty successful model because it enables them to do the things that they do really well, building this library, and then allow the browsers to do the things that they do really well by having specific APIs for each. But you're entirely correct. It would be nice if everything was the same everywhere. That's simply not where we are right now.
I have another question.
Sure.
About like extending on the malicious extensions. Say if an extension currently requests like X number of permissions, and on a remote update, it's going to access like more permissions to do some other thing which shouldn't be doing. Are there any things to prevent that? Like say one of the, like it might not be intentional, like one of those popular extensions was like putting affiliate links on like Google search. Like basically it could put a content script and do anything you want. Like what are steps to prevent those?
Well, currently if an extension requests more permissions, then it'll be disabled on update until the user specifically enables it. So they'll get an info bar at the top of, or actually it's not an info bar anymore, it's a pop-up that says, this extension requested more permissions, it's been disabled, and you can re-enable it from that menu. So it gives you the ability to determine that the extension is now requesting more permissions and to evaluate that based on what you know that the extension does. What we'd also like to see is people moving more towards optional permissions, which we introduced a few months ago. I'm not exactly sure when it came out. But by having optional permissions, we don't actually, if you request new optional permissions in a new extension update, we don't give you this info bar because it actually doesn't change the way that the extension works. But it gives you the ability then to explicitly request those new things from the user when the time is right. So geolocation, for instance, if I need to interact in some way with the user's location, I can make geolocation an optional permission, and then when the user actually interacts with the extension and needs that new permission, I can ask them then when it's really quite relevant to the way that they're working. Thank you. Okay, one more. Two more.
Hi, I work at Genentech, and we're trying to deploy Chrome for Business for all of our employees at Roche and Genentech. I was wondering, and we also have, like, currently we just use the consumer Chrome browser and build extensions on it.
Mm-hmm.
Are there any limitations to using Chrome for Business that, as far as building extensions goes, or is it just the exact same sort of functionality?
You actually have a really good mechanism for deploying Chrome inside of Enterprise. So it's very enterprise ready. You can deploy it as an MSI package and deal with corporate policies via, like Active Directory or something. Via Active Directory, you can actually set a list of extensions that should be auto-installed or that are banned within the context of an organization. So by using group policy in the same way that your IT department is probably quite familiar with, they'll be able to deploy Chrome locally and actually deal in a very detailed manner with the extensions that are pre-installed and also the extensions that aren't allowed to be installed.
Okay. Thank you.
Thank you. Great. Thank you very much for your time. If you have any questions later on, I'll be at office hours pretty much all the time. So just come hang out. We'd be happy to answer any questions that you have. Thank you very much.